So with the triangular prism, well, we want to find the area of the base. So I'm going to draw a little line over here. And it's helpful to draw the bases, or at least just really one of them, because they're going to be the same. And so we have a triangle. Now, what are the dimensions of this triangle? What are the side lengths? Okay, so they're all, so 6, 6, and then this side is the same as this side over here, so 6. We have 6, 6, and 6. Guys, you want me to leave again? You can go back to the office if you want. So we want the area of the base. Now, what's the area formula for a triangle? Okay, so 1/2 of the base times the height. Do we know the base or the height of this triangle? Yes. We know both of them? No. Which one do we know? We know the base is 6. We don't know the height yet, so we need to find the height. Okay? What else do we know about this triangle, though?
It's the same side. All sides are the same, so it's going to be...
So all the sides are the same, which means all the angles are the same. So what's the measure of each angle?
30. 60.
So 180 divided by 3 is 60. So if I were to draw just that slice right there, this would be 60.
30, 90.
And so how long is this side right here?
3.
Okay. And so we have a special right triangle, 30, 60, 90, right? So 3, so this side would be 3 square root of 3. And so our height is 3 square root of 3. So we have the area of our base, which would be 1/2 times the base of the triangle here, which is 6, times the height, which is 3 square root of 3. And so we get a base area of 15.588.
Base or the height?
So the area of this triangle is 15.588 square centimeters. So going back to our volume now, our volume formula says the area of the base times the height. In other words, we get each of these areas, and we're going to add them up h times, basically. That's the idea. And that way we can stack them up, we get the volume. And so we have 15.588. And then our height is the distance between the bases. So if we draw, here's our other base. We can't see the back half of it, but the idea is the distance between these two bases is the height. So in this case, this is our height, and so our height is 10. And so our volume, if we multiply 15.588 by 10, we move the decimal place over once, so we get 155.88. Now thinking about units here, we have volume. And so keep in mind the units on area would be square units. The units on the height are just the units. We have centimeters squared times centimeters. And so what are our units going to be?
Centimeter cube.
Cubic centimeters. Centimeters cubed. Yep. Okay, so again, just recapping, define volume. We identify the base. This is why we started off with nets and identifying the parts of the prisms. Get the area of whatever that base is, using whatever the appropriate formula is. This happened to be a triangle, so it's half base times height. What if the base were a rectangle? What formula would we use to find the area? Length times width, or base times height. If it were like a regular polygon, what would we use? No, not for a regular polygon. What was the formula for the area of a regular polygon? 1/2 Kaufman times perimeter, right? So we use whatever is appropriate for the shape of the base. Okay. Now we want to find the lateral surface area. So lateral, remember, just means the sides. So what we're doing here is we're finding the area of the side. That's really, we find the lateral area, that's the idea. We're going to find all the sides and add up those areas. So lots of times it's helpful to kind of draw a picture. That may be a net, or it may just be one side, whatever. So So I'm going to draw the net of this figure. So let's see here. If I were to draw the base, not the base, the what's flat right now on the surface, that'd just be a rectangle. All right. And then if I unfold this, I would have another rectangle over here to the right, and then a third rectangle over here to the left. And then I'd have the triangles. But we're looking for the lateral, so I'm going to leave the bases off. Okay. So whenever I draw my net, I'm going to actually leave the bases off. Now, what are the dimensions of each of these rectangles? Well, let's see here. The bottom here is 6, and this is 10, so this would be 6 by 10. And then for the right one here, well, let's see here. This is 6, and this side is 10. And this one is 6 by 10. So we really have 3 congruent rectangles with an area of what for each one? Well, 6 by 10 is 60. And so we really have a lateral area, I'll call it A sub L for area, lateral area.
180.
Would be 3 times 60, which is 180 square centimeters. Now to find the total surface area, I'm going to call it A sub T, total area. We take the lateral area, and we want to add on the bases. And now how many bases do we have? 2. Now what do we know about the relationship between these 2 bases? They're the same. So we know we're going to have 2 times the area of the base. Now did we find the lateral area already? Did we find the area of the base already?
Well, yeah.
Yeah, we found it right up here, right? And so we don't have to do any real new calculations per se, nothing super complicated anyway. We're just going to take our previous values and substitute them in. So we have 180, which was the lateral area, plus 2 times 15.588, which was the base area. And so we evaluate that, and we get 211.176. Double check that. Now, what would the units be on this? So it's area again, so square units, so square centimeters. Is that right? Oh, that's close enough. Okay. Okay, so again, just to kind of go through the process again. Identify the bases, draw the figure, find the area of that base, and find your volume. Notice we use the area of the base again in total surface area, right? So we're not just doing it for one calculation, we're actually doing it for 2 calculations. Okay. Look at example, the first assignment problem. It says find the volume of the prism, use the shaded face as the base. In other words, again, that means this right here is our base. So when we go to our area for our base, let's draw that rectangle. Okay. Now, what's the area formula going to be for this base? Base times height. That's fine. More length times width, whichever one you're more comfortable with. Now this is the area of the base. So what are the dimensions on this rectangle? Okay, so we got 3 for the short side. Why not 6? Okay, so that would be the other side, right? So this is what we're talking about right there. So those are the same. So we have 3 by 5. So the area of our base, well, it's 15. 3 times 5. So our volume, which is the area of the base, times the height of the prism. Now, what's the distance between the 2 bases of this prism? All right, so there's our other base. And so we say, well, how far apart are they? Well, that's this distance right here. 6. So we have 15 times 6. So our volume would be 90 cubic units. I'll go ahead and take a couple minutes and find the lateral surface area and the total surface area. drawing picture, it could be very, very helpful.
I lost it.
Well, yeah, the top, right, which is like a bigger, and then the front. Narrow. Well, sometimes the net is in the way. You really need to worry about the net, or you just imagine that to the top and to the front.
So the rest of printing like this on the